Welcome to our third lecture on gravitation and harmonic motion. We have three equations here, two that we already know, the spring constant equation with force and stretch, and potential energy. Now sometimes these are used in conjunction with the other harmonic motion equations for the spring and the pendulum. But what we're going to do is really emphasize this one right here with period and frequency. So the period is the inverse of the frequency. So if you know the period, you can do an inverse to find the frequency, or if you know the frequency, inverse of the period. The main thing on this is know your prefixes, because either one, you're going to deal with very small numbers or very large numbers. So to make it easier to write, you will need become or just kind of review your prefixes, metric prefixes. So T is, now this is a 1, okay? Not an L, but a 1. And on your calculator, if you know how to use this button, it makes your calculation a little easier, and you can just hit that and say x to the minus 1. So let's look, the frequency of a pendulum. Now it doesn't matter whether we're doing with a spring or a pendulum. This works. So the frequency, so I got T equals 1 over F, and this is 0.34, 1 over F, and the frequency is in hertz. Okay, and there it is. Now in some textbooks, and sometimes your teacher will say, since they're an inverse, might say F equals 1 over T. Just be careful and don't do it if they don't want you to. So we're just starting out with this. Okay, it says I have a oscillating mass. Well, it doesn't matter if I have the frequency, and I'm looking for the period. So T is equal to 1 over F. Okay. Now you notice that's a large M, so that's mega. The easiest way to do it is write down the number first. Now mega is 1 million, or 10 to the 6th of whatever, and there it is, and we have seconds. And you should get a very small number, since this is the million. That's a million times per second, so each one is not very long. So if you get a positive exponent, you might want to check your math. Here's another one. I want to know the frequency, and I have a very small period. So T is equal to 1 over F. So I got 35, and using this, okay, nano is a very small number with a a prefix of a billion, which is to the negative 9, 1 over F, and F will be in hertz. And we'll do one more and sum everything up. Okay, is 1 over F. Okay, the period, okay, that's 1 over. Now doing this is 1.5. Now giga is to the 9, right here in your computers, and that's in seconds. Now these can be used in conjunction with the pendulum equation and the oscillating mass equation, in case you want to figure out the length of a pendulum, or the mass or of a pendulum. You need to put mass on the spring that you need to oscillate at a certain rate. So these can be used with a pendulum or the oscillating mass equation. If you remember, if you have any questions, feel free to contact